Hi everybody. Okay, today on Coding Bytes, I'm going to just do a short little project which shows you how to link the CX7000 and just purely using it to interact with I/O. How you can use this with something along the lines like Python. So I'm going to pick Python in this instance. Not a Python programmer myself, but I know enough to be dangerous with it, I think. So questions come up quite often where we have people who are writing software, for example, in .NET, Python, JavaScript, and they come to us and say, well, how can I just purely interact with I/O? That's all I want to do. I want to have a PC in which I'm running my own code and all I want is I/O. I want no controller. I don't want to run TwinCAT as such. I don't want to write any programs in TwinCAT, that type of thing. I just want to be able to interact with the I/O that we have available. Now that's completely possible. Now, obviously we've got things like bus couplers where we support multiple protocols. So for example, things like Modbus TCP. So if you have those libraries in your language and you can take control of, as in you can speak Modbus TCP, that's all possible. You can use one of the bus couplers for that, attach a whole host of I/O to it and interact with it that way. Now, the downside with bus couplers is they are typically limited in what terminals you can put on the side of them. So they definitely can't do things which require DC clock. So the XFC terminals where you can get multiple values back, or you can't support things like third-party devices. So for that, you need a true controller that's going to run TwinCAT, configured in TwinCAT, that type of thing. Because the as in the bus couplers, they tend to have their own web interface. You can pick what I/O of backoff that is in there, but maybe you don't want to do that. Maybe you want something else. And so what I'm going to do is show you a possible solution. So the kit that I'm going to show you today is I have a small demo rig next to me. This is a CX7000 demo rig. And all it is, CX7000, I've got an input channel, an output channel, and an analog input channel on the side. So this is the layout that I'm actually going to use. And I'm going to show you how to set up an incredibly basic TwinCAT project, which will allow me to interact with the I/O without writing any PLC code. We won't actually have PLC code in there anyway. The other thing as well, just to bear in mind, is the CX7000. I mean, it's a great bit of kit. CX7000, yeah, it doesn't support distributed clocks. So again, you're limited with some of the terminals that you can use, but it will definitely support third-party EtherCAT slaves. If you want to do things like distributed clocks and interact with other hardware that requires that, you only need to go one level up. So CX81 range, so 8190, one of my favorite bits of kit. Again, that introduces DC clocks. You can use the entire hardware at that point there. So this is comparable. What I'm going to show you with a CX7000 is completely possible with any of our controllers. Yeah, that's it. So licenses wise, when we interact with the I/O side of things, so you've got TwinCAT ADS, which is free of charge. TwinCAT IO is free of charge up to a certain level of performance level anyway. And then you've got TwinCAT PLC over the top of that. We don't need to have the PLC license. The other nice thing with the CX7000 is all licenses is included. So everything we're going to do now, that's already included when you buy a CX7000. If you were to buy the CX8190, for example, again, at that performance level, you're not going to be paying for I/O. So it's only when you need the PLC license that has a cost associated with it. Otherwise, I/O, again, free to use. Yeah, there you go. You just buy the hardware. Lovely. Right, so getting set up. So to start with, what I'm going to do, we'll start with the TwinCAT project. So that's going to be sort of the most easy to consume because, again, this is sort of our bread and butter at the end of the day. I tend to go off and just hide the ones that I'm going to be using. What I'm going to do is just go on my network. And now I've already established a route to this. So again, if you're unsure of establishing a route, all we're going to be doing is a broadcast search on my network. And I've got the little CX7000 just currently attached to it. You can see it turn up. I say add route, type in the password, hit OK, and we're done. Now, things that we will need during this is this AMS net ID. So I'm just going to copy that because when we speak via Python, and we're going to use pyads, which is actually, it's unofficial. That's not a backoff library. So again, users of Python have come together and said, yep, we're going to implement the open, well, it's the free protocol of ADS. They've implemented it in Python, so that's not a backoff thing. But again, I'll show you how to use it with that. Okay, so far so good. I'm going to make a connection with it and just swap so it's on the right type. Let's just move that one out of the way as well, just to finish it. I'm going to put it into config mode, because then I can scan the IO. Scan the IO. Not all IO can be found automatically, so that's typically things that are hanging off the end of things like RS-232, all those good things. Things that just natively don't support discovery. But yeah, typically if it's like EtherCAT, it will find everything. I'm going to scan for boxes. So this should mimic what I've got in my drawing here. So input, output, and log input by the time it finishes. I'm going to put it into free run as well, just so we can see it. So there's my input, there's my outputs, and there's my analogs. Now, if I want to run this, I don't think I can hide, I can hide the PLC configuration as well. Wow, there we go. Get rid of that as well. We're not even going to use the PLC configuration. So if I want to expose all of this via ADS without a PLC program running, there's a couple of things I need to do. So the first thing I need to do is go into device 1 EtherCAT. I'm going to be selecting this first one, image, ADS, enable the ADS server. That there is my port. So we're very used to port 851 for doing interacting with ADS. That's 851 is the first PLC project. In this instance, no, you're getting this big long number. This is the port for the IO. It's made. The other thing as well, I'm going to do create symbols. Now, I've already had a quick run through just to make sure the PyADS supports this. Create symbols. If you're using a library that supports these long symbol names that become generated, so for example, if you're using our .NET side of things, absolutely create symbols. We may as well tick it. It will make some nice symbol names for you, which are all based on how it's laid out here. The example I'm going to show you now with pyads is it's unable to support that level of symbol. It's too large for it. When I try to read from it, it fails. So with this one, I'll leave it ticked because it doesn't really matter, but we are going to be using index and offsets to be able to access this IO. So which is a typical thing. I mean, people are used to using index and offsets anyway. So create the ADS server, may as well create symbols as well, although we won't be using the symbols directly. So that's that. So that's the first part done. So EtherCAT itself is now ready to have an ADS server automatically applied. If, however, we build this, we get the typical warning, say error message. It's a warning just saying, hey, in order for EtherCAT to start, you need at least one variable to be mapped so that it knows how fast EtherCAT should be turning ultimately. So what we're going to do in here is I'm going to go into tasks, add a new item, and I'm just going to say this is my task, my IO, and okay. So there's my task. I'm going to leave it as the 10 milliseconds, although you can set this to whatever you need be. And what we can do is go into, I'm going to go in this route because you can do it the other way, but this is by far the easiest. Excuse me, is go onto EtherCAT, EtherCAT sync unit assignment. And what I'm going to say is, hey, all of you terminals, can you be looked after by task IO? And that's good. I didn't need to click add then, by the way. That was just clicking OK. So now that that's been done, all of these have now been assigned to be looked after by this task, which means that they know how fast they're going to be updating. Now when we do rebuild solution, that error message has gone away. So that's it. So we've defined the IO. We've assigned it to a task, so it's going to be being polled at the 10 millisecond rate, and we've enabled the ADS server so we can now pick it up. That's it. So what we can do is activate the configuration and let it go into run mode. There's no PLC program, so there's no notion of logging in and pressing play. That doesn't exist in this instance. We've just activated the configuration. TwinCAT has now gone live and is in run. That's it. That's enough. Right. Okay. So now into the world of Python. I'm going to use VS Code for this, but again, whatever browsers you wish to use. Again, it's not my first language, as in these definitely aren't languages I use that often. So again, could be a little bit ropey with this one. And let me just bring up a terminal. So a new terminal. So we need to do a certain amount of setup first. So I know Python you can use virtual environments, which means that libraries are tied to a virtual environment rather than it becoming part of your global Python install. So I'm just going to set that on up. Also, we'll do, and I've got some notes up here as well. So Python m make a virtual environment, and we'll just call it environment. I'm actually using the plugin. So this is, in other words, it's just said, hey, we've just seen that you've just added a virtual environment. Do you want us to use this as VS Code as well? So this is the official plugin for Python with VS Code. So, and it just means I get a play button up the top here, and it understands what this virtual environment is as well. So that's the first step. Next, I'm going to be activating that on my side. So I'm going to go into the environment folder, into scripts, and activate, I think it is, activate. So now we're in this virtual environment, and from here I'm going to do pip install pyads. So that is the library, which is ADS for Python. So far so good. So now we can start using this. I'm just going to move that slightly out of the way, just so I've got a little bit more typing space, and import pyads is now the first part, and this is now happy with this. I'm going to, let's just see, rather than sit and watch me type all of this in, I've got some notes before, so I'm just going to copy some of these things across, just so, again, just saves a bit of time. So I know I normally live code, but yeah, there's only so long you want to watch me write pyads connection, blah, blah, blah. So the first thing I'm going to do is make a PLC variable. I'm going to use pyads and make a connection. And this number here, this is the number when we look in my this BTN we've been given here. That's what I'm connected to. So this is the net ID of this device. The fact that I've made a route to it means that all of the ADS routing is done. Now, had this have just been an install of a system where I've installed Python and now I need to speak to this, I need to set up a route between my system and here. But because I've got TwinCAT XA installed and I've had to establish a route anyway from this PC to there, that's already done and dusted. So that's where that number comes from to start with. The next thing, 27905. So if we check on that, just go into that image 27905. That's the port that it has decided upon for me to establish a connection to. Next, we're doing PLC open. So reading and writing from the symbols, what I'm going to do here is just copy out a line as well that I've got, just so we can just talk through it instead. So what I'm going to be doing is the pyads has got this notion of that you can define a symbol. So what I'm going to do is I'm going to have a symbol which is just my input, PLC get symbol. And what this means is once I have this symbol available, I can do things my input .read, for example. Oh, sorry, okay, my other language is coming in, and we'll just do a print read, just so we can see the response from this. So this get symbol, there's a few ways of actually getting what symbol we actually are referring to in the PLC. So you can see in here, I'm using the style of index group, index offset, and PLC type. So where do these come from? Index group, index offset. So this is our typical setup. So you can ask ADS to go and get a symbol by name. What actually happens behind the scenes is it goes, hey, TwinCAT, I've got a name of a symbol. Can you resolve this into an index and offset for me? It provides that back to the person that's asked for it, the software that's asked for it. And at that point there, if I want to read or write, it's by index and offset. So that's the typical. So you get this sort of few-way jump between resolving a symbol name, ultimately. So what we can see in here is if I just go into, I can use scope and target browser. This will bring my target browser up. I can open up the connection that I have. I can now see this port, and these are what it's created for me on this ADS server. So if I just expand that out just a little bit more, we can now see that if I want to read the first channel of my digital input here, that's so my index is F031 and my offset is 1E0. So let's just make sure that's the same compared to what I had originally. 031, let's just move that sideways. And my offset is 1E0. So that's going to be my first button right there. It is, again, I've double checked and it's working okay. The style, actually the data type of this is a bit, but again, pyads only supports PLC type Boolean on this one. Now, yeah, you could get a little bit unstuck with that, depending on how they've implemented it. The test works fine on mine, so all of the inputs and outputs, they don't clash with each other, that type of thing. But you have to bear in mind that under the hood in a PLC project, a Boolean can occupy an entire lump of memory, and that memory is 8 bits ultimately. A bit is a very special part, which means it can occupy 1 bit of that byte. So I had to run a few tests because I didn't want it to accidentally just class it as 8 bits and always keep picking the first one. So yeah, but it does seem to respond as we expect it to. And that should be it. So the last thing I'm going to do is just do plc.close just to tidy up my connection. And let's hit play. There we go. So at the moment, if I look on my rig, that button is currently pressed. So I'm just going to unpress the button and hit play, and we can see it's false. So we're successfully reading from an input channel with absolutely no PLC code, and we're just establishing an ADS connection. This ADS connection is just using TCP/IP, and we're setting up a symbol, and then we're reading from that symbol. And then obviously the rest of the code here will be your code, your implementation, but it's as simple as that. We can do the same again for outputs. So let me just, we'll just convert this to an output instead. So get the symbol. If we just open up this one, my output channel. So this one here, FO21, 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 138, 138, nice. It's a Boolean data type of, yep, Boolean data type, and I'm just going to call that my output. Now from here I can do things along the lines of my output.write, and I can write this true. Oops. Near the end of the day, there we go, things are stopping working. Right, nice. Going to run it on my side. You can't see from the camera over this side, but my little lights just turned on. And again, if I wanted to turn it off, and actually I can prove that that is actually working, because if I call up this will actually give me, I'm just going to move this out of the way because I do want to still keep this. My online value you can see here is 1. And if I move that over and we set that to false, try and get all of this in a way that you can actually see. There we go. And hit play, you can see the output's just gone false as well. So good, yeah, so far so good. Lastly, just to prove out that we can read analog channels too. So I'm just going to copy this one. Oops, let's just move. There we go, it's trying to be clever and highlight things for me on my behalf. I'll just call it my analog input. Now analog inputs, very similar. We're just going to go down inside here, and again all of this is possible. You can pull any of these out. Unfortunately it's not working with the symbol names, because normally the symbol names you could have used this name here and it would expose it and say, yeah, no worries, I can pull it based on that one there. You do unfortunately have to use index and offsets, but that's okay because you can define these index and offsets as constants in your program. Yeah, it's a very small price to pay for what is a free implementation of something where you can just interact with any I/O. I mean, that could be high voltage measurement terminals. It just allows your PC to connect to anything, any I/O terminal that's supported by anyone who's an EtherCAT slave at the end of the day. So yeah, very handy, very handy. So I'm just going to pull the analog value, so 3072 analog value. This one here, it's an integer, and that's F030. F03036, F030, and the offset is 36. Now this one is a PLC data type of an integer, so I'm just going to swap that over to int. And we will do a print again on this one, and we will print that out as my analog input read. And that's it. So we can see here I've got an analog value of 13,317. And if I go to my channel, this one here, just move that out of the way. Okay, it's moving around a little bit at the moment, which is understandable because it is an analog. 13317, 13317, 13316. There we go. So yeah, and if I wanted to write analogs to the, if I had an analog output card, completely possible too. And that's it. So again, I'm not a Python programmer, so apologies if that was a little bit sort of broken and I've done it in a different way. But hopefully that can show you that by spinning up an ADS server, disabling the PLC, there is no PLC code in there, spinning up the IO, if that was third-party IO, 100% it can take it. Just remember the CX7000 doesn't support DC clocks, so that you are limited to some of the terminals that you can put on there. But if you need to implement that and you need to pull back, for example, so would you use DC clocks? Would you use oversampled terminals? Probably not, because you are talking to it from a non-real-time system, which means you might lose data, as in you might miss data because it's not fast enough to keep up with EtherCAT. But if you needed to, then you would go just up a single level to a CX81 range, and then you'd be able to do absolutely any of the terminals that we support. And that's it. Okay, I'm going to push this project up here, write a little README file of just how to get started. I hope that helps, and then I'll see you in the next one.